Hey everyone, welcome back to my channel EduVibe. Today we will start with the practice questions of the part which we covered in last lessons. So today we'll do some practice questions including the electrical iterations, electrostatic force, Coulomb's law and the vector analysis. So let's start with this practice question. So first practice question is: a neutral metal sphere is touched to a net positive when they generator. What charge does the sphere gain and by the what method does it occur? So they mention that one neutral metal sphere is touched through a net positive generator. So this means that touched is means they contact. If they contact, so this means it is a conduction. So they mention that what method it does do. So it's a conduction method because this neutral metal cuts with this. So they direct contact with that generator, which is net positive charge. And they mention what charge does gain and by what method. So one method is conduction. And what they do, the electrons will be transferred. The electrons will be transferred from that neutral sphere to the this generator. Why the electrons? Because they're negatively charged, and this was positive, so this was negative. So the negative and the positive can attract. So they do attraction. So then the giving the sphere a net positive charge. So this means that the sphere gets a net positive charge in that case, as this was the physical contact. So this all have to be in the one like short answer you have to make, and you also mentioned that which method it is a conduction one. Yes, occur through conduction. So that's how the theory question related to conduction induction works. So next question again with the same type of figure, but now a neutral metal sphere is brought near the generator while it is near. You touch the sphere with your finger and the charge does the sphere gain and by with the method. Now this was not with the direct contact, but this was near close. This was close to that sphere, that generator, and we touched that with our finger. So what will happen? The sphere will be polarized with the side closest to the generator. As we all know that if this was positive and we have a neutral charge with positive negative, we have the random charges. But if they come contact with this, so the net they will polarize and the negative charge goes over there and positive charge goes over there. Why the negative charge goes the closest to that negative one? Because this was positive and this was negative, so they will attract to each other. So our finger will give us a sum. So because of finger we are also neutral sphere, so we will transfer that some negative electrons to this. So the farthest from the generator being positive, the closest side is goes negative in that case. The side will trap the electrons through you, and as you are standing on the ground, we are standing on the ground, and the ground gives a charge on our finger, and the charge goes to that neutral sphere. So this will kind of the charge migration we do. So this is charge migration. So overall negative charge will gain in this, and by the which method? So the method, so method is induction. So when it is under direct contact, so this means this is conduction. If not, it closes to this, or we do the grounding, so that means it's the induction. So that's how you can identify the which question is conduction or which is induction. Friction is like when we do a rubbing in this, when we involve rubbing in the question. So next question we have on electrostatic force. So they mentioned that 2 point charges A and B have a charge of 4.0 microcoulombs and minus 250 microcoulombs respectively. They are briefly blocked into contact without grounding and then separated by a distance of 0.05450 meters. We have to remind the magnitude of the electrostatic force. exert between the two charges after contact, and we also have to find the number of electrons transfer between the charges during the contact. So they mentioned that this is the contact, so this means this is the conduction. So we have two charges over there, and we have to find the electrostatic force and the number of electrons. So both the formulas will, all three formulas will actually cover in this. So for the first one, we have to find that electrostatic force, but for electrostatic force, we have to find the Q, because if I write over there, we have formula K Q1 Q2 upon R square. So we want that Q1 and Q2. We can see that if it is both are equal or not. So we have to do some distribution like we do. So first we have to find that total Q, which is, so 4.0 microcoulombs plus negative 2.50 microcoulombs, and we have to divide this by 2, because in conduction, after they contact, they will separate the equal charges. So this means that Q, when we divide this by 2, we get 0.75 microcoulombs. So this is our Q in that case. But we want that delta Q after that when we calculate the N. So for that, for the part of this electric force, we only need that Q for this. So here in that case, our Q1 is equal to Q2, which is equal to Q square. So Fe is equal to K Q square upon R square. Now we have to put things in this. So K is 8.99 into 10 raised to 9 Newton dot meter square, Coulomb square, and our Q square is, we find 0.75. We all know that micro is the prefix, so it's a value of 10 raised to a minus 6 coulombs. So this should be square and divided by 0. This one is our R, 0.0450 meter square. So when we calculate this, when we divide this, we get about 2.4972 newtons, and we want 3 seconds, so it's 2.50 newtons. So this is our electrostatic force between the two charges. So that Q we have to use when we find the electrostatic force. But that Q is not valid when we have to find the number of electrons, because we all know that this is the A part, and when we calculate the number of electrons, we have delta Q divided by E. E is the elementary charge, N is the number of electrons, and the delta Q we have to find. So for delta Q, we all know what is formula. So Q after conduction and minus Q before conduction, absolute of this. So after conduction, we get like this. This was the after, and what is before one? We have to know that these are two of the charges we have. We have to take the bigger charge. So this was the Q before. This was Q after. So we take absolute of 0.75 microcoulombs minus 4.600 microcoulombs. So when we calculate, we get 3.25 microcoulombs. So now this has to be plugged in this. So this 3.25 into micro is 10 to the power minus 6 coulombs divided by 1.60 10 to the power minus 19 coulombs. This is elementary charge. Coulombs cancel. When you find, you get 2.03125 into 10 raised to power 13. But you want 3 sigmas. So 2.00 into 10 raised to power 13 electrons. So this is your number of electrons which will transfer between the 2 point charges. So in the one question, we will cover all the 3 formulas. We cover the charge formula, we cover the electrostatic formula, and we also cover the number of electrons we have to find. So that's how like all the formulas used in one question. This question makes about 4 to 5 marks question. If you all do all things correctly and by sequence way, so you get 5 out of 5 or 4 out of 4. So let's move on to the next question. Sometimes when you do the electrostatic force equation, so you get the graphical analysis too. In the forces and fields, in the next units, we also get this type of question when we do the graphical analysis with those equations or the formulas we have. So like this question is also involved that type of question when we do graphical analysis. So in this, you all know that we have to find the slope, then we have to find the things, then all the things are same in this. So how this question works is for the first time we will doing that question. So let me explain for you. So the following graph shows the electrostatic force plotted as a function of the inverse square of the distance between the two electrostatic charges. The two charges are identical in magnitude. Using graphical analysis, we have to find the magnitude of the charge. So we have to find the Q. So big Q we have to find because they mentioned that the both the charges are identical. So this means that Q1 is equal to Q2, which is equal to Q. Here we have to take the Q, not the Q square, because Q square is goes to the root because we basically have to find that Q on this. So now we have to do this something. So this is the electrostatic force. So this means that this is our Fe, absolute. And that inverse square of distance between the charges is our r square because this is inverse, so we do 1 upon r square. So Fe is on the y-axis and 1 upon r square is on the x-axis. So we have to know that what is the formula for this. So we know that Fe is equal to k q1 q2 upon r square. So Fe is equal to k, we won't know this is q square upon r square. We have to arrange this is type that Fe is remain on this because this is our y. You all know that it is our like y is equal to ms plus b is our standard form for the slope. So that's how this was the y1 and this was the x-intercept as the case in this. So this is like the case we do. So this will remain the x-axis and that plus b remains aside and that m is your slope. So that b is not used in this most of the time. We use this m y is equal to ms we use. So the y is our y-intercept which is this and we now take that 1 upon r square from this as the x value. So we have to multiply this as isolate type. So that Fe is equal to kq square remain like this. But that r square if goes out, so we can multiply this by 1 by r square. So this remains the same thing of this or this. So now this is your y, this is your x, and this is your slope. So you get the slope in from there. So your slope, you only need the slope is equal to kq square, but you want that q. So the q is equal to slope upon k and you take whole root. This is a square cut. So you know the k, you have to find the q, but you not know the slope. So for the slope, you use the gain formula. You all know that y2 minus y1 upon s2 minus x1. This is the major formula we have to use. So now you want 2 points on this graph which are very accurate to put on this to find the slope. So the most accurate points from my side, I take something from this one, this point is some accurate point. So this is point about 0.5. You know that this is the signs given to us, so it's meter minus 2 have to take comma, and from here this is approximately 1.6. Again we have 10 raised to a minus 10 newtons. So this is the point. From here I take this point, you take any other points from the graph from this line which is best fitted. There are some points, so it's the accurate values you get. So I will tell you what I answer got, and if you got something other, so this is also right. So this point is like 3.0 meter minus 2 comma, and we have accurate of 13.2 into 10 raised to power minus 10 newtons. So this is your 2 points, and you take this as x1 y1, this as s2 and y2. Now you have to put that points on this graph. So our y2 is 13.2 into 10 raised to power minus 10 newtons minus Our y1 is 1.6 into 10 raised to the minus 10 newtons divided by 3.0 minus 2 minus 0.2 meter minus 2. So when you find the slope, you get about, when you solve this with minus and to divide, you get 4.64 into 10 raised to power minus 10 Newton meter square. The minus k. So this is the slope. Now you have to put the slope in this and put the k value and that the q. So slope you get is 4.64 into 10 raised to power minus 10 Newton meter square upon k is 8.99 into 10 raised to power 9 then dot meter square upon Coulomb square, and this goes whole root. So when you do some calculation, then meter square cancel, Coulomb cancel, the square goes with this square. And when you solve the both and we do the root of this, you get about 2.27 into 10 raised to power minus 10 coulombs. You get in 3 seconds, 2 said this, so 2.3 into 10 raised to power minus 10 coulombs. So that's how, when you do the graphical analysis, you can find anything. So you do the mode, when we do the mode formulas, we'll do the graphical analysis again for that equation too. So this is for the electrostatic force equation. You will get this question as the same. Sometimes the wordage is changed, sometimes something is changed in this question, but you get the kind of that question when you do in the examination or in development. So you're getting also that in numeric response too, not in the written, but you get in numeric for sure. So that's all the what you have to do, and answer is this. So if it is 2.0, you get 3.9, you get 2.4, 2.5, all are the right answers because there's some range of that correct answers you get, because the graph is not very accurate, sometimes more accurate, so all will get the same answers, but this graph is not very accurate, so you get some different answers, difference of answers you get. So there's not like a huge deal you get. So next question is from the wet analysis when we do Coulomb's law. So let's deal with this. This is a different kind of question from the Coulomb's law. We'll do the simple ones, but this is now for like x component and y components when involved in this. So this is like some long or lengthy questions we get, like we do in momentum and impulse. So, but the concept is same, but just the formula was changed. So how can we do this? So let's discuss now. So the 3-point charges we have the identical charges of 2.0 microcoulombs. So all the 3 charges have the same charge, are aligned as the shown in diagram below. Determine the initial net electrostatic force acting on charge B due to charge A and C. So that's kind of the thing you have to know. Okay. So first we have to find the free body diagram. So how can we find? So for free body diagram, so this is the kind of something we have over there. So from C to B, we have like in this angle. We have like in a, not a straight angle, we get in like a obtuse type of angle, you know. So this is like this type of angle we get. So this CB force, and that AB is straight. So it's like AB force is straight. And we have that angle over there. When we sum it out, we get the 40 degree of angle over there. So this kind of thing we have. So you can see that if we do a straight, this is the east one. So in that case, we take north and east as positive when we do dealing in the vectors. So we take north and east as positive. So the first thing we have to all the same, that we have to find the force of this AB, then the force of the CB. So it's the same thing because we have know all the things and we just have to find. So let's move on to this part, because this was the easy part first to have to do. Then we move on to the vectors, components. So for force from A to B, this K, QA, QB, your QA, Q and B is the same. So we go K, so Q and QB is the same. So I take Q squared and R square of AB. So when we do this, So you know this, and we have 2.0 micro is 10.6 coulombs, and we have to do the square of this. Upon we have from A to B, we have 5.0, so this is in meters, it's 0.050 meter square. So when you solve this, you get about 14.384 newtons. So this is for force from A to B. For force C to B. So the same kind of thing you have to do, but this is C and B. So K is 8.99 into 10 is 2.9 meter naught newton meter square coulomb square. This is again the same 2.60 into 10 is minus is coulombs, and square of this. Now we have 7.0 over there, so it's in meters, which is 0.070 meter square. So when you find this, you get about 7.3388 newtons. So we take the non-bounded value because we have to carry it out again. Then we do the something. So now we have AB and CB. So now you can see over there that which is from A to B. If you from A to B, this one, this is only the one direction. This follows only the straight line, but our C to base goes on like a nice this angle. So if we take this as the x vector and this as the like a net one, and this was our y vector somewhat, if we like extended this and we made this as a y vector, this was the x and this was the net, and we have an angle from here. So from here, we get our x component and the y component of this. If we made that only that thing in that thing, so if we made that, so we take like this as, so this is our y, which is FCBY, and if we take this into this, it is an opposite direction, so west, so CBX, and this is your net one, which is also really fine, which is force of from C to B, which is 7.3388 newtons. So this is already fine for you. This one, you have to take this one, not the 7.0, because 7.0 is a distance between the charges. But we want that net one, which you have to calculate. So from C to B, if you find from X, so this should be negative because it was west direction, west was negative, we take east as positive. So it's minus 7.388 newtons, and we have to find this base, so this is cos 40 degrees. So when you find this, you get about negative 5.6218 newtons. For CBY, you take as positive, so this is not direction. So this, now we have sine 40 degrees. So CBY, so when you calculate this, you get about 4.7173 newtons. So this is for the Y and this is for the S, for CB and C. Done. For the H1, so now we have to find the total one. For the H1, we have that just H for this, because this AB goes only one direction, so it's nothing matter, we take this as this. So we have to find the FS total and then FY total. So for FS total, we have FAB, just FAB. From CB, we take FCBH. So FS is equal to, when we calculate, make sure this is the negative sign over there. So we have to take this negative sign. So when we calculate, we get 8.7622 newtons. So this is FS, which is total one, and FY is just FCBY. We don't have like over there. So this is equal to 4.7173 newtons. So we take Fs and Fy. Now we have to find the resultant vector. For resultant, both in positive, so they go in the respective direction. As this goes into the west east direction, this goes to the west direction, and this is our net 1. So this is theta we have to find and the magnitude we have to find. So for the net one, we all know what we have to do. Fs square plus Fy square. So F net. So Fs is about 8.7622 Newton square plus 4.7173 Newton square. We have to take non-bounded value for this. And when we calculate, we get about 10.0 Newton, or you can say 10 Newtons. So this, and for theta, you have to take tan -1. So Fy upon Fx, Fy is 4.7173 Newtons upon 8.7622 Newtons. And when you do tan -1 of this, you get 28 degree. So it's north of east, and yeah. So your net force is equal to 10 Newtons, and we have 28 degree north of east. So that's how you have to find the net force with the x and y component when we're dealing with the electrostatic force. So that's all the work you have to deal. First, we have to find the respective forces, then their x and y components if they have, and then the magnitude and the angle. So that's how work you have to arrange for this type of questions. So this all for this practice questions. We cover, like, from all the topics we cover 1 or 2 questions. So learning by simple EduVibe, learn smarter but not harder. Please like, share and subscribe to my channel. If any questions, let me in the comment section. I hope this video was for you. And in the next lesson, we start with the electric fields. The next part is like a big part. We cover so many lessons in this. Then we do the practice question for this too. So that's all for this video. See you in the next lesson. Till then, stay connected with EduVibe.